What's a good approach to creating a solid design? Each class needs to have a single responsibility, be open to extension while closed to modification, support list-off substitution, have segregated interfaces, and be dependent on abstractions. There are a lot of considerations. Here are two suggestions for tools that can help move from a story to a design. It can help to make paper cards, yes, paper, showing a class described by the responsibilities and collaborators. These CRC cards can be used to gather ideas and details of the class design. Automated test code is just as important as the application code, and I'll describe that separately. I'd like to start by looking at an old technique called CRC, Class Responsibility Collaborators. The definitive guide to this is a white paper by Scott Ambler written way back in 1998. The CRC process is designed to be simple and flexible. The goal is to refine the details of the class definitions. A way to start object-oriented design is to identify all of the nouns in the problem domain. Each noun may be a class of objects, or it may be a property of an object. It's often pretty easy to identify things like sample or correlation or data file from the problem statements in the user stories. A static structure diagram will show how these various candidate classes relate to one another. Then, get a stack of paper cards. Yes, paper. Annotate the cards to describe the classes. Each card has a class name on the top, the responsibilities for that class, and a list of collaborators with the class. For developers new to object-oriented programming, it can sometimes help to also get a pad of sticky notes to represent instances of each class. These objects are transient things that come and go during the application's operation. A class is an enduring thing. It is the template for the individual objects. Cards can start looking like this. Each paper card has a class name at the top. It has a summary of the responsibilities and then a list of collaborating classes. In this case, they're annotated with used or uses to emphasize the kind of collaboration. Then we can add details by walking through different scenarios. The cards are used to examine a scenario or story. Find the card that is responsible for the story, step through the actions the controller must perform, then examine the other cards to look at the collaborating classes. We can ask which class is responsible, and we may need to add classes to be sure all the responsibilities are accounted for. This may require several passes to be sure the classes, responsibilities, and the collaborators are all understood. The class design is often clarified by arranging the cards on a whiteboard or a tabletop based on the relationships. This can further help identify modules and packages. It can help to identify the parts that are heavily used and the parts that may be tangential or perhaps completely extraneous to the user stories. Once the scenarios seem to work, then the solid principles can be reviewed for the class defined on each card. Is the responsibility statement succinct? Are the interfaces properly segregated? Has list-off substitution been considered for any class hierarchies? This may lead to more revisions of the CRC cards. This can lead to some more scenario tests to be sure that the cards are complete and consistent. The open-closed principle and dependency inversion principle are more focused on coding techniques than high-level design. We apply those principles later when we get closer to coding. Good code doesn't happen by accident. CRC is one way to articulate design details to be sure that the classes are designed properly. What's a good approach to getting a solid design? As we've noted before, there are 5 general design principles, and these can lead to a lot of other considerations. Here are 2 suggestions for tools that can help move from a story to a design. In the last section, we looked at CRC cards. In this section, I want to look at automated test code. Tests are just as important as the application code, since it's essential to test every class in isolation. Building unit tests turns out to be an important part of designing a class. I think that considerations related to testability can help assure that the solid principles are being followed. This is one of the ideas behind test-driven development. The guiding concept under test-driven development is a blunt statement. If there's no automated test, the feature does not really exist. The guiding idea here is to provide a definition of done for any particular feature by saying the software is done when it passes the automated acceptance tests. And that means the definition of done can be formalized as a suite of test cases. A search on phrases like acceptance test-driven development and test-first development will yield a number of resources to help do this. The idea is to write test cases first, and then from that create code that passes the tests. We'll look at describing features using a formal testing language named Gherkin. I find it helpful to describe software tests using a given, when, then kind of statement. Given some class in an initial state, when some interaction or method is evaluated, then there's an expected result. This is the Gherkin language, which is handy for describing tests. The unit test framework in Python has a setup method that handles the given part. There's a run test method that handles the when and the then parts. A PyTest fixture is often the given part of a test, and a test function implements the when and then parts of the test. Here's an example test case spelled out in detail. It starts with a definition of the scenario, provides the given conditions that must be true. It provides the when statement for the action we want to carry out, and it provides then clauses that show what we need to evaluate to determine if the test passed or failed. Here's a test case using the PyTest framework with some annotations to show how we turned the Gherkin given, when, and then concepts into actual test code. The given clause became some mock objects to provide the initial state. The when statement became a method invocation, and the then statement became a series of assertions to determine if indeed the test was passed. Tools like Behave use Python modules to implement the Gherkin steps. I prefer to write the steps manually because it serves as a way to affirm the solid design principles have been followed by the code being tested. When the tests are hard to write, it indicates potential design problems that need to be reviewed. In addition to unit tests, Python also supports doc tests. These are test scenarios that are included in the documentation strings for classes and method definitions. They're relatively easy to prepare, and I think they're an important part of being sure the solid principles are part of the design. These tests tend to fit the Gherkin model of having a given starting condition, a when action of some kind, and then a then consequence that shows the results of the action. I like writing these to confirm the design really fills out the solid principles. Test to design bumps into the solid principles in important ways. Generally, all tests should reflect the single responsibility principle. Some tests must be written to evaluate the open-closed principle. We'll need to write a general test for an extension to an abstract class. The tests will often reflect interface segregation. If an interface has too many features, the tests tend to grow also. And test coverage tools can show if interface features aren't being tested properly.